guys, I hope that this is in focus, but I basically just had a question about directional cloning, so I thought I'd really quickly send this video to explain it, because I know you got your test on Friday. And this could be something on your test, hint, hint, but also just like it's a really hard concept. So I don't see why they wouldn't try and test your knowledge and extend your knowledge by asking about it. So if we just look at this one little like sequence of DNA, it's GGATCC, and then let's just say that this is the 5 and this is the 3, and then this is the complementary 5, and over here this is the complementary 3. What's going on here is we've got GGATCC, and then if we go the exact same way, 5 to 3 on the way back, we have GGATCC. By now you've probably realized I know I'm rambling, but this is a type of sequence, and it means that it reads the same back to front, which we would call palindromic sequence. And this type of sequence is cut by a very specific type of endonuclease, and it's called, I think, orthodox type 2. I can't find my whiteboard markers. It's cut by orthodox type, please someone double check this is by memory, orthodox type 2 nuclease. And let's pretend it cuts between the GGs here and here. But the point being here is this is symmetrical. So my point here is, if we're trying to get this gene and we're trying to pop it into this plasmid, and we cut it with an orthodox type 2 nuclease, which is, it has a palindromic recognition sequence here and here, we basically got two ends that are the exact same. So if this gene that we have here in black is a, if it's a desired gene and it gives us a really cool protein, gives us the love heart protein, the thing is, it can only be read this way for us to produce our little love heart protein. So when we're trying to put this into a plasmid, how can we be so sure? Let's just say, actually, I'm going to do this. Oh, Jesus. I'm going to do this up here. How can we be sure that we're going to be putting it in 3 to 5 if these are the exact same restriction sites? Like, how do we make sure that this gene is running this way? If you haven't figured out the answer yet, this concept is called directional cloning, because we are trying to figure out a way to clone this gene into a plasmid with a specific direction. What I asked you before was a trick question. This will go in literally anyway. Once you pop it in, if it has the exact same recognition sequence and it's been cut at a palindromic part here, it's going to go in whichever way. So we actually can't be sure that we're going to get our desired love heart protein from this plasmid, because we don't know what way it's going to be put in. How do we combat this? Great question. Let's just say here we have endonuclease 2 and endonuclease 3. What we can do, if we redo, we get our gene here. We'll just say that this is 3 and this is 5. So we want to be popping the 3 end at the 3 end here, and we want to be popping in the 5 end at the 5 end here. The way we go about this is using is really important. We use two different endonucleases. We use two different restriction enzymes / endonucleases. Sorry, they have the same name and I'm getting confused. We use one here, meaning that we use that one here. So at the 5 end of the gene, if we want it to be read 3 to 5, because we build in 5 to 3, we pop the 5 end here and we use the exact same nuclease for that section. Same goes, well, what are we doing? Endonuclease 2, sorry that they're both black, I'm out of colors. 3 end here, 3 end here. That means when we pop this gene in, the sticky end and the sticky overhang is only going to click in with the plasmid at the 5 end, meaning that we can successfully make sure that this gene is only read in that direction, meaning that we will get our desired love heart protein. Thank you so much for listening. I'm so sorry if that made no sense. I hope it made some sense.